Hi friends, welcome back to another session on SQL. In yesterday's session, we had discussed about subqueries. We did a lot of examples on subqueries and we talked about triggers. How you can write a function to perform a certain activity and then you can trigger that function which will perform the activity. So under triggers, we had seen only one example yesterday. The agenda for today is to continue our discussion on triggers. We will see one more example. Then we will talk about indexes, and then we will look at the DCL commands, which are grant and revoke. Okay, so this is the agenda for today. And I'm already connected to the PG admin tool, and I'm connected to the training database over here. Okay, now to do the data setup for trigger, yesterday, what was the example we saw? We calculated the total cost by multiplying sales with quantity. Okay, upon multiplying sales and quantity, the total cost was computed, which was a procedure. And through a trigger, we invoke that procedure. How and when? Whenever a record is inserted into the table, the procedure is triggered, which will compute the total price as a product of sales and quantity. Okay, now here we're going to look at another example. We already have a table called as employee with us. We had created it earlier. So here we don't have to create the table all over again. Employee table is there. I will show you the data that I have here in the employee table. This is the data. We have information for different employees, the date of joining, their employee status, okay, some salary, and the last updated timestamp. Okay, and their location. So this is the information available. Now, whenever the record for an employee is updated, whenever any sort of modification happens to the employee, then we need to update the last updated field with that timestamp of whenever the change was made. Okay, that is the requirement. So date of joining is fine, but when we come to last updated, this is not getting updated. If you look at the timestamp in both the columns over here and here, it is the same. It is the same. This is not getting updated. In fact, when I was explaining the update command to you all, I asked you all to make a note of this thing, that even though the location was changed, the last updated data did not change. So that is what we are going to achieve now. Suppose the status of an employee is changed to inactive. Let's say Priya quit the organization. She left. Okay, she quit the organization. So the record for that person, which is showing the status of the employee as active, must be changed to inactive. So when this change happens, when the record for that person is changed to inactive, the timestamp of when that modification or that update is made to the record, that needs to come here. Not the date of joining, but whenever it is modified, whenever any information for any record here is modified, the last updated timestamp should reflect that latest timestamp whenever the update was done. Okay, it is quite meaningful and sensible, right? To understand when was the record updated. Now, how do we do it? Okay, so we need to create a function that will assign the current timestamp to this field last updated. I need a function which is going to assign the latest timestamp now to the last updated field. So how do we write a procedure for this requirement? The syntax is to create function. The procedure is called as a function. Okay, whether you call it function or procedure, technically we call it a function. I need to create a function. Okay, I will follow proper syntax also, convention. So I'm going to create a function with the name update on status change. And remember, the name of the function ends with empty parenthesis. It does not accept any arguments. You don't have to give anything here, but as per the syntax, we put empty parenthesis. Then, what is this This is basically going to return trigger. Okay, it returns trigger. The next line is as. And then we start the procedure with this symbol, $2. We are going to start the functionality. We're going to start the logic followed by the $2. Begin. I'm going to begin it. What do I need? New. Why am I saying new? Because this is happening when the record is being modified. So we should use, when you're deleting a record, you will have to use old. When we are inserting, when the function is going to be triggered upon insert or upon update, this keyword is new. If the function is to be triggered with delete, then it would become old. Okay, then we should use it old in this place of new. Last updated, the name of the column. This has to be updated, the last updated column. What should we put in that column last updated? The current timestamp, which can be called with now function. Okay, the current timestamp is supposed to be returned. And then return the new value. Okay, return whatever is the latest timestamp now, which goes into this field, that is supposed to be returned. And we have used begin keyword to indicate that the logic is starting. So we end it with the end keyword. After that, before begin, we have $2. So after end, we will have $2. Okay. After that, the language used. This is a special language. The syntax, it's a special language which is called PGSQL. So this is my function. Okay, so what is this function doing? Whenever there is a change, whenever there is an update that is done to the data in the table, it is going to assign now, meaning the current timestamp, to the last updated field present in the table. And when I run this, okay, 1 minute. I think I already have the function here. So I will delete it. Okay, and I will run it again. And then okay, let me just copy it. Maybe some sort of syntax error I'm doing. What's the difference between the previous one and now? I don't know. Okay, so this is the syntax. Okay, we are creating a function with the name, empty parenthesis. It is return. It is a return to the trigger. As open the dollars, begin, write the logic, end, and then close it with dollars. We open it with dollars, we close it with dollars, and the language is PGSQL. Okay. Once this is done and the function is successfully created, now I need to create a trigger to invoke that function, right? Function is ready. Now we need a trigger that will invoke that function, that will trigger that function. So when should this trigger be pulled? When user updates the record, right? Whenever the user is going to update a record. So I will now create a trigger. Status updated on. This is the name of my trigger. Okay. I need this before the record is updated. So when update is run, first we need to take the latest timestamp and then we update the record with the latest timestamp. On which table do we want this to happen? On the employee table. On the employee table. And this should happen for each row that is updated in the table. This should happen. What is it supposed to do when a record is trying to be updated? What should this trigger do? It is supposed to execute the procedure. Which procedure? the function that we have written earlier. Okay, it is supposed to execute the procedure. The name of the procedure is this, which I will copy from there and paste it here. Okay, so what will this do? It will execute this procedure. Which procedure? This one, this function. When will it do it? While updating the record present in the employee table. Whenever any row is updated, for each row that is being updated, this is going to get triggered. Which this trigger is going to invoke the function. The function is the one that will actually go and update the date and the timestamp with the latest information. Okay, so the trigger is ready, which will invoke the function. Now I need to write one update statement, right? Because this trigger is supposed to work upon update. So I will say update employee, set status to inactive. Okay, let's say some employee where the name of the employee is equal to Priyadarshini. Okay, so let us assume that this person left the organization and therefore the status in the employee table for this person is supposed to be changed to inactive. So when I go and run this update query, when I write the update query, it updated the record. But what else would have happened? Update would have invoked this, and this trigger would have called the function. The function would have changed the last updated field with the latest timestamp, not just setting the status to inactive. So when I now query the data and check, okay, when I now query the data from this table and check the data within the table, you can notice how for Priya, whose status has changed to inactive, the timestamp is updated. So the record was inserted on 20th of March. It has been updated on 23rd of March. The moment a change has been made, the last updated field got updated. Okay. So like this, we can make sure that we capture the latest timestamp in the last updated field. This is quite commonly used by database designers because every time when a record is modified, we would definitely want to keep a track of the last updated change. So these are triggers which help us perform certain activities. Again, you may not be using triggers as much as a data analyst or a scientist, but it is good to know these things. So it would give a good impression on the interviewer also, or even at work, you can even suggest to your DBAs that they can do something like this. Okay, so this is about triggers. Now we will proceed to the next concept under the agenda that we have today, which is indexes. Now, what is an index? Index is nothing but it's like the glossary. Okay, let's say you're reading a very big, huge book with a lot of pages in it, and you're learning certain concepts from that book. At the end of the book, usually, there will be a glossary, right? With the words and all the pages where that concept is discussed, right? It will have some list of important topics and list of all the pages where that topic is discussed or where examples related to that topic are given. I'm not talking about the table of contents. Table of contents having chapter 1 is in page number 3, chapter 2 is in page number 4. That is okay, but I'm talking about glossary at the end of the book. Index is more or less like that. Okay, it's more or less like the glossary. So we'll try to understand the concept of index here by creating a few tables, and then practically we will see the application of index. For this, I will be using MySQL. We can create indexes here as well in Postgre also. However, for explanation part, to drive the point home, to convey the concept properly, I feel MySQL is more better because there are certain commands which run there which help us understand the concept well. Okay, so I'm going to switch to my terminal. And connect to MySQL, okay? Later, I will show it on Postgre also. Just to explain the concept, I would like to use this. Okay. So I'm in MySQL terminal. Okay. I don't know if I should be able to make it bigger. Yeah. I think this size is good, right? You should be able to see properly now. Okay. I'm going to create some tables here. I'm going to create one table called as employee table. The commands are already shared with you all. So I'm going to create a table called as employee table. But in MySQL, we can't directly create a table. You see, in Postgres, we actually choose the server, then we choose the database, and then we go to the query tool. So the system knows in which database we are, under which server, as what is our user ID, everything it knows. Okay, whereas here we need to actually tell it what database we might want to use. I'm logged in as root. My username is root. I also gave my password. So it has given me access. It is allowing me to use my SQL server. Okay, however, I will have to see what all databases are present. This is how we see the list of databases and in MySQL. Show databases is the command. Okay, show databases. So here, how do we see the databases in Postgre? We just click on databases, expand it, and we can see the list of databases, right? Whereas in MySQL, this is more like, this is from the command prompt, right? So you have to, given the command, show databases. Now I'm going to create a database, 360DigiTMG in here. So create database, followed by that, the database name. Database is created. After it is created, I need to tell it that I want to use this database. So in Postgre, how do we create a database? We right click on this and select the option to create database. Give it a name and the database is created. So how do we select the database? Simply by clicking there and then going to the query tool. So it is connected to the training database on that server, isn't it? But here we need to tell it. Everything needs to be given explicitly. Okay, I have created the database. Now I need to tell that I want to use that database. So use database 360DigiTMG. Now it will switch to that database. Okay. Okay, sorry, just use the name of the database. Database changed. Look at this last one, database changed. Means we are now inside that database. Okay, now I'm inside the database. Once I'm inside the database, I'm going to create the table. Okay, I'm going to create the table by copying this query over here. What happened? Okay, let me just type in the command. Create table and table. It will have an ID column. Okay. Okay, I was just copying the PostgreSQL command over here, hence the error. Serial doesn't work here. Okay, if I use the command serial to indicate that something is supposed to be automatically incremented, it does not work here. So I need to use a keyword called as auto increment. Okay, so employee table ID is integer and it has to be auto incremented, and then employee name as a varchar of, let's say, 20 characters, and salary as an integer. This is going to be the structure of my table. Okay, so I have to call this integer, I will make it primary key also. All right, table is finally created. Now we have a command called as describe. Describe, which will help us see the structure of the table. Okay, it is telling me that I have 3 columns. One is integer, employee name and salary, of type ID, employee name and salary. This is of type integer, varchar 20 int. no for this is not null because it is a primary key and it has auto increment. We have not given default values anywhere. The rest of the two can be null because we didn't define any restrictions. So now that the table is ready, I'm going to insert some data into this table. Okay, I'm putting data for a few employees into the table. Okay, so data has been inserted. Now let me just do a select star from employee and show you the data from the emp table and show you the data. Okay, so these are the complete list of employees for which we have information now. So I created one table in the MySQL server, and this is the list of employees for whom I made an entry into that table. Now my requirement is, let's say, to search for the employee whose salary is 55,000. Suppose I'm given a task where I need to search for the employee whose salary is 55,000. Okay, that is Priya. Priya is getting a salary of 55,000. So how do I do it generally? How do we write the query? We will say select star from employee table where the employee name, where the salary, right? Where the salary is equal to 50,000, 55,000. So when I run this query, what will happen? It will fetch me the details of the employee whose salary is 55,000. But how did it do it? How did it go and search? In what way did it search in this table to get me that data? It does a sequential scan. Okay, it does a sequential scan, means it goes through each and every record, checks the salary in all the records, and it picked up that employee whose salary is 55,000. It scans through the entire data. And then it is fetching us this output. Okay, here if there is a command called as explain. We can explain the query that we have run. So when I use the explain keyword and I ask the system, MySQL, to explain this query that I have written, it will actually show us exactly what it has done. So you see, it's a simple select statement that we have written on the employee table. Okay, and how many rows? Just focus on this part. How many rows did it have to scan through to identify all the employees with the salary of 55,000? The complete 10 records of data it went through. Here I have 10 rows of data, right? So it scanned through all the 10 records. It does a sequential scan. It goes through everything, all the 10 records it looked at, and it identified the person with that salary. Now, because we have 10 records, it's okay. But imagine if you have a lot of data, if you have 1 million records, and to search for one particular item, it has to scan through all the 1 million records and then fetch you the data. It will be a pretty, time-consuming process. It will take a lot of time when the data is huge to run a sequential scan on the data table and to fetch the data that we need. It's going to take a lot of time. So how do we optimize this? Okay, we can create something called as indexes. Now I'm going to create one index and then we will see what the query does, how it runs. Okay, so I'm going to say create index and then we give a name to the index. Syntax is the same: create index, create table, create database, create function, create trigger, create view. Here, create index and then followed by that the index name. I'll call it salary index. I want an index on the salary column. On which table are we creating this index? On the employee table. On which column in the employee table? Salary column. So index name, you can give anything, but generally it is good if you give the name of the column followed by that index. It's easier for us to understand on which column we have defined it. Simply for our own convenience, we can do this. Okay. So I'm creating an index with the name salary index on the employee table on the salary column. So what will happen when we create an index? Oh, how is it going to impact? How will it store the data when the column is indexed? It is going to arrange this data in a sequence. And then, so what will it do is, this is our data, isn't it? So it's going to take this data. It's all coming. Just a moment, let me. Wait a moment, I will run another query here. It's going to store the data like this. Internally, it would be storing the data like this. Okay. So when I created index on the salary column, on this table, internally, it would be it will allocate memory for that index. The data in that column is stored in the memory with index. And what will happen is it will remember the position of these members. After sorting the data, it remembers the position. So 50,000 over here is in position 1. It is in the first position in the table. So it will store position 1 here. 55,000, where is it? What is the position in the table? It is in the 4th position in the table. So it will store 4 against this. Position is 4. 60,000, 1, 2, 3, 4, 5, 6, 7, 8. It is in position 8. So in this glossary, imagine this like glossary, it will have 8. So if you're looking for 60,000, you go to row 8 and pick up that record. Okay. Next is 65, which is in position 9. Okay. So it is going to store 9 against this. 75,000 is there in position 5, and it is also there in position 6. So it's going to store 5 and it's going to store 6 here. 80,000 is in position 3. So it will store 3 here. 90,000 is in position 2. So it's going to store 2 here. 95,000 is in the last position, position 10, and also in position 7. So it's going to store 7 and 10. Okay. So this is what will be present in the index. This is what is going to be present inside the index. So when you create an index on the column, the data in that column is first sorted and stored in the memory with the position, with its position in that table. Now, when you fire a query to select the data where the salary is something, the where clause has this indexed column in it. The where condition, where clause has the indexed column in it. Then it will not go into the table and do a sequential scan from top to bottom, everything, and then fetch what we need. Because this is indexed, it will go here. And here data is already sorted, right? So it will directly pick the position number 4. I want where the salary is 55,000, right? So here it will reference the glossary. It will reference this index. It knows that it is in position 4. So directly it will go to position 4 and pick that record. Okay, that is the beauty of the index. I hope you all got the point. Now, after creating the index on the table, let me run the select query and see. I'm going to run the select query and get the data from the employee table where the salary is 55,000. Of course, it will fetches the data for the employee Priya. But when I run the explain part, now look at the number of rows that it has scanned. Why? Because here we have index on the salary column, right? Earlier, there is no index, nothing. But here I have salary index. So it is referencing that index and therefore it is able to fetch the correct record without having to do a sequential scan on the entire table. Number of rows, directly it went to the row that was needed. Earlier, it did a sequential scan. went through all the records. But now, after the index is created, directly it goes to the row because it knows where the row is and it fetches the data. Okay, so it does not do a sequential scan on the entire data anymore. That is the beauty of an index. The retrieval time will become very slow. Retrieval time in the sense, the time taken for the system to fetch the record from the table and display it to us will get reduced. It will not take a lot of time. Almost instantaneously, it will give you the result no matter how big your data is. Okay. Now let us, I will give you a demonstration of the same thing on Postgres also, because all of you are using Postgres. So I hope you all got the concept. The reason why I use MySQL is to show this explain part, which doesn't work this in the similar way in Postgres. Okay. So first step is to create the table, of course. If you already have the table, any table with this data, you can keep it. So I'm going to run the query to create the table. Then I'm going to run the query to insert the records into the table. Once all the data is inserted, we can select the data and see. So this is our data. Okay, we have our table ready and all. Now, I need to fetch the data for the employee. Where, let's say the salary is equal to 55,000 only, as earlier. Okay, here index is not created, okay? And the data is pretty small. It has taken some amount of time, 0.94, okay, and it fetched the data. Now I will run this after creating an index. Okay, now I'm going to create an index. How do we create an index? The syntax is create index followed by the name that we would want to give to the index on which table and which column within that table. So when I run this, index will be created. Sorry. Once the index is created, okay, now I will fire the same query again. It took much lesser time, slightly lesser time than earlier. Why did it take lesser time than earlier? Because earlier it ran a sequential scan, but now it doesn't do a sequential scan. It will refer to the index and fetch the record, the point of interest, the record that we would like to use. How do we drop an index? Okay, after creating an index, suppose we realize we don't need it, then is there a way that we can drop this index? We can drop it using the drop key command. Drop what? Index, and then the name of the index. That's it. Drop index and the name of the index, and it is gone. Okay, so this is about indexes. Now let me check if there are any questions from you all. So we covered the concept of triggers and we covered the concept of indexes. I hope everything discussed so far is clear. If you have any questions, you let me know. I'm looking at the chat now. Can we use both insert and update triggers for the same table? Yeah, we can use. Each of these triggers are going to be separate only, right? You can use. So when you insert a record, some trigger will run. When you update a record, some other trigger associated with updating of the record will run. When you're deleting a record, some other trigger with respect to deleting a record will run. So you can have triggers for insert, for update, and for delete on a table. Yes, you can have multiple. Okay, so that's the only question. All right. Now we will proceed to something called as DCL commands. So as a part of this training, this is the 9th day of the program. As a part of this training, we spoke about DDL commands. What are DDL commands? The ones that deal with the structure of the table. The ones which basically alter the structure of the table, right? Like creating a table itself. When we drop the index, it will not affect the table. No, only the index where the data is sorted and their positions are sorted, that is no longer available. So when you run the select query, it will do a sequential scan on the entire data in the table. It has to run through all the rows to fetch the data. So the retrieval time will be significantly high. When you put an index, the indexed data is stored with the positions like a glossary, and it will reference the index and fetch the data. So the retrieval process will become faster. But when you drop an index, it is not going to impact the table in any way. Okay, data in the table will be intact. All right. Okay, so DDL commands which are creating a table, altering the structure of the table, dropping a table, or truncating the data and then recreating the table. So these 4 commands come under DDL. What are the DML commands? The ones that deal with the data that is present in the table, where we try to insert the records into the table, where we try to update the records into the table, where we try to delete the records present in the table. Insert, update, and delete of the rows or the tuples. Then we saw about DQL command. What is the DQL command? It is select, right? The select query, which as a data analyst or a scientist, you would be working extensively because you would be retrieving data from various data sources and analyzing that data on various tools. So select is something that you need to focus on a lot. Select. Apart from this, we have something called as DCL commands also. Now, what is DCL? Okay, DCL stands for Data Control Language. DDL we know is data definition language. DML is data manipulation language. This is data query language. This is data control language. And the commands we have under this are grant and revoke. Okay, which is again mostly the responsibility of a DBA. But because we are trying to cover everything here, I'm just going to tell you about this also. Okay. Okay. Let us say you are working in a project, okay, and you have access to the data in the tables that are loaded here on the server. So you can query the tables and create whatever reports you might want to create. Then a new resource is recruited, or a new resource, a new person joins your project, and that person is also going to work on the project along with you. Okay, a new person has joined who will be helping you, who will also be analyzing the data and building prediction models on that data. So that person also needs access to this database, right? Only when they have access to the database, they will be able to retrieve the data. They will be able to manipulate the data and work with that data. So we need to give them access. In order to give them access, whoever other people are joining the project, if we need to give access to other people, first, we need to add them as users. They should be given the permission to access the server with some login credentials. So we need to add them as users. So how do we do that? If you look down here, no, there is login role. So we have our training database, isn't it? Where we had the schemas and all that. Under schemas, we were able to see all this, but you will also find login group roles after the list of databases. Let's just minimize databases. After databases, there is something called as login group roles. Okay, when I open that, there is one user called as Postgres. This is the super user. Postgres is basically the super user who has all the privileges on the server. Procedures we discussed, along with triggers, we discussed functions. That is the extent to which we will be discussing procedures in the training. Tomorrow is the last session. Tomorrow is the last session. Is index used only when we have, only when you have large data, it is good to use indexes. When you have small data, I don't think index is required as such. Because anyway, data retrieval on small data sources is pretty fast. Okay. Right. So we were talking about the role. Only Postgres is the only user here right now on my machine. And I am that person. And Postgres being the super user has access to do everything. The privileges, all of them are on. This person is the super user. He or she can create roles for other people. Okay, they can create databases, inherit rights from parent roles, can do backup of the data, they can take backup. So super user basically can do everything. Now, a new person who has joined needs to be given access to this database, training database. And you need to recollect this. What is this convention? This is the name of the database. Training is the name of the database, right? Postgres is the name of the user. And this is the name of the server to which we are connected. Right. We had discussed about this naming convention. Now, to this database, which is training database, I need to give access to one more person. So I'll have to create a user. How do we create a user? The keyword is create. Create. What is it that I'm trying to create here? User. Let me end the I need to create a user. Then with what name? I will call that user PS1. And I'll set some password to this user, which I will have to later on inform the user. Remember that this is your password. So I'm creating a user with the name PS1 and giving them a default password. Okay. So when I run this query, user is created. Where can I check whether the user creation is successful or not? When I go here and refresh the login roles, you can see PS1 as another user in there. Okay, so user is there. Just because I added this person as the user, will this person be able to access the tables? First, let me connect as that user. Okay, I'm going to connect as that user here. So I'll go here and make a new connection. Right now, the query tool that I'm on, the terminal that I'm on is Postgres. So I'm going to add a new connection. I hope you're seeing here. Over here, we can add, okay, new connection to the PostgreSQL 15 server. The database is training database. User is PS1. I'm now going to access the information as PS1. Okay, the user PS1. Save. Yes. And password has to be entered. 5 once is the password. So who is logged in now? I'm logged in as PS1 now. To the training database present on this server. I'm logged in as PS1. Okay. Will PS1 be able to query the tables in the database? Will this user PS1 be able to query the data in the database? No. Permission denied for the table employee. This person does not have the permission. Will this person be able to update, let's say, salary? Wait, first we will grant, let us first grant, select, okay? I need to grant the permission. Who can grant permission? Who can give permission to PS1 to fire a select query and retrieve the data from the tables in that database? Super user has to do it. Okay, so we'll go there. I'll log in as the super user now. I'm changing the terminal to Postgres, who is the super user. And I will say grant. Okay, as a super user, I can give roles. I can set permissions for other people. So I will say grant select on employee table to PS1. Let this person be able to run a select query on that table. I'm granting only the select permission here. Okay, so selectively you can give them permission, select query. So now let me switch to PS1. Now when PS1 logs in and tries to fire the select query, it will work because this person has been granted access, has been given the permission to run a select query on the employee table. This person will now be able to run the query and see the data. Okay, now will PS1 be able to update? Let's say we'll update employee table, set status to inactive. Set the status field to inactive, where let's say the name of the employee is equal to, now let's say this time Akhil left the organization and this person's status has to be made inactive. Now please note that I am logged in as PS1. PS1 is trying to update a record in the table. What will happen? Permission denied. Because we didn't give that person permission to update any records. So not possible. So now what has to happen? The Postgres user, the super user, should grant the permission. So what should he grant now? Grant update on employee to PS1. Give that person the ability, the option to even run a update query. Once the permission is given, now if PS1 logs in and tries to run the update query, it will work. Okay, this person can now update. And when I run the select query, this will also work because this person has access, right, to run the select query. And look at that. Status is inactive for Akhil. And look at the timestamp. We had already written the procedure, right? We already wrote the procedure. We already have a trigger in place, which will get triggered whenever the record is updated. So timestamp got updated for Akhil. Okay, now will this person, PS1, be able to delete from employee, let's say where the status equal to inactive. So we're just cleaning up the data now. All the people who have left the organization whose status is inactive, we want to remove them. We don't want to keep them in our employee table, their data. So will this work? This will not work. Why? Permission is denied. So this person cannot delete. So what do? The Postgres, the super user has to grant the permission. Grant delete on employee to that particular user. Only when the permission is granted. Now when PS1 logs in to the server and that tries to fire the delete query, it will work. And now when I select, you see those two records whose status was inactive, they've been removed. Okay, similarly with insert also. So if this person tries to insert data, again, there will be an error saying you don't have the permission to insert. So again, we'll have to go here and grant insert on employee to PS1. Who should run this query? Not PS1. PS1 can't give access to himself or herself. If I run this, it will say you don't have privileges to grant. No privileges were granted. You don't have the permission to grant. Right? Who should grant? The super user should be able to grant. Only that person will be able to grant. Okay. So when I run this query, it is successful. Now, if PS1 wants, PS1 can go ahead and even insert a record into the table. Okay, you all can try out insert. After granting the permission, you can try inserting a record while you're practicing. So after, let's say this person came and based on the necessity, we gave this person select access. We gave this person the access to update records, to delete records, and to insert records. Now the project is over and this person leaves, moves on to another project, or maybe leaves the organization, moves on to another organization. So all the permissions which were granted to this particular user PS1 are now supposed to be revoked. Okay. So how do we revoke the permissions that we have given that person? So we can use revoke command. Revoke. What is it that I might want to revoke? Let's say I want to revoke the permission delete from, delete on employee table from PS1. From that person, I'm trying to revoke the access. I need to be the super user to do that. So to this person, whatever access was given, I'm revoking the access. Which access? Only the delete access I'm revoking. Not everything, only the delete access I'm going to revoke. So when I run the query and the access is revoked, okay, when I run this query and the access is revoked from the person, now if PS1 signs in or logs in and tries to run a delete query, what will be the problem? No permission, because that particular permission has been denied. This person can no longer delete the records. Let me now revoke. As Postgres user, I will go in and I will revoke update access. Update on employee from PS1. So when I revoke the update access, as expected, if PS1 now tries to get into the server and try to update any record, it will say permission denied. You don't have the access to run an update query. Will this person be able to select? Yes, because we have not revoked the select permission yet, right? He or she can select. So I'll go now and revoke select on employee from PS1. So grant to, revoke from. Grant to, revoke from. So when I revoke this as Postgres, I'm revoking the access on select. So now when PS1 logs in, this person does not have the option to even fire a select query. Permission is denied. Okay, so we can add multiple users and we can set up a password, let them know about their password. They can connect to that server. Upon connecting to the server, they will be able to access the information depending on the permission that has been given to them. So I'm going to now revoke insert on employee from PS1. Okay, even the insert access that I had given, I'm going to revoke. Sorry, PS1 cannot revoke, Postgres has to revoke, right? Postgres has to revoke. So everything has been revoked from the person. Select, update, insert, delete, everything. Now, instead of, if we know upfront that this person should be given the option to do everything, this person should not have restricted access that they can only run a select query or only run an update query or only run a delete query or only an insert. Let's say we don't want to restrict the access. We just want to grant all permissions to that person on that table. So you can just say grant all on employee to PS1. You're granting all the permissions to that person. So they get all the access. Now that I have granted all the access, when PS1 logs in, PS1 has been granted all accesses. In one go, we have given all. So select is possible. Okay. Let me change this. Komal is there. Okay. Update is possible. It will not throw an error. Delete is possible. Okay. This person can even go delete, and insert also is possible. He can do anything and everything. So you can grant everything in one go if you feel that person has to be given all the role accesses. Similarly, I can revoke all on employee from PS1. I can also revoke all the permissions in one go. Who is revoking again? Postgres is revoking, okay, not others. Postgres is revoking. Only the super user has this ability. So when I run this, all accesses are revoked. So now when PS1 goes in and tries to even fire a select query, permission is denied because everything, all the permissions are revoked in one go. Now, let's say this person has even left the organization. PS1 quit and moved on to another company. Then we might want to completely remove the person as the user. Right? We may not even want that person to stay as a user here. We would like to remove the user completely. How do I remove a user? How did I create a user? Using the create command. Create user, username and password. So to drop or delete, drop. Drop user and the name of the user. So when I drop this user, right now PS1 is a user. If you look on the left side on the browser, you can see that this Explorer part. When I run this and drop the user and refresh the login group roles, is it not getting removed? Okay, I think it didn't get refreshed properly. Permission denied to drop. Okay, I need to drop. PS1 cannot drop himself or herself. It's the Postgres user who has to do it. So I'm going to drop the user PS1. Now that the query is successful, when I refresh it, you see PS1 is gone. Only the super user Postgres is here. Okay. So depending on who has joined the project and what kind of permissions you might want to give the people who are working in the project, depending on who has left from the project, and depending on what all you might want to revoke, what all permissions you might want to revoke, you can accordingly do these things. Okay, so today we talked about procedures, triggers, how to write a procedure, and then how to invoke the procedure, how to trigger it. Then we talked about indexes. It's like there's a question here on indexes. When we use index to retrieve the data and then we delete it if not needed. Yeah, if you feel an index is not needed at a later point of time, then you can definitely drop the index, which we saw now. After you have created an index and you have selected all the information, if you feel index is not necessary, you can drop it. No problem. The person who grants access, will the person connect to the server through his own? Yeah, that person will be connecting to the server from their own respective machines. Okay, so it's a client server architecture, right? Server is hosted on one machine. The rest of the machines accessing the server are the clients. This is client server architecture. Here, server and client both are the same. This is my server and I am only the client. Okay, this is my server where I'm working. Postgres is my server and I am only the client also. From the same machine, both client and server are there. But you can have clients logging in from other machines also. Yes. Indexes, mostly on numerical columns only we put them. Can we give it to multiple tables or all tables at once? You give to the database. You grant access on the database level, you can grant. Are these commands the same for other databases also like MySQL and SQL Server? Tool specific, there could be some changes to the commands, Chaitra, but most of these commands work in the same way. 80% of them, I can say, work the same across all the tools. So all these grant, select, create index, drop index, all these will work exactly the same way, but the procedures and all that would be different for each tool. Their syntax could be different for each tool. Okay. All the common commands, 70 to 80% of the commands, all the basic commands are the same across all the tools. But again, tool specific, the syntax might change. You have to refer to the documentation of the tool that you are working upon, where you can see the tool specific syntax and correct it. Okay. All right. Thank you all so much. I hope I have answered all the questions and I hope everything we discussed today is clear. Thank you all so much for your support, your joining and attending the sessions. And I hope each day that you're investing here, the 1 hour that you're investing here is turning out to be fruitful. Tomorrow will be the last session where I will show you how to connect to this data source from data visualization tool like Tableau and how we use the data from here to perform the analysis over there, creating different charts, etc. Okay. That is not in scope. In the scope that was decided, TCL is not in scope. Commit, rollback, and save point, they come under TCL commands, transaction control language. Okay, if you want, I'll take it up tomorrow, no problem. Tomorrow, if we have time towards the end of the session, I will take it up, okay? All right. Anything else, any of you? Okay, thank you all so much. See you tomorrow for the last session, and please do like the video. I'm assuming, I'm guessing that it should be a little helpful to you all these sessions. So please do subscribe to the channel. All the people who are new here, kindly subscribe, and who are already there as subscribers, it would be great inspiration if you can like the video. Thank you. Bye-bye.